Hello, in this video I'm going to build a TOPS network that will automate the process of loading the prepared base meshes, running them through the network, and saving the detailed high poly models and baked maps. So now that I have all of my base meshes prepped and ready to run through my network, I'm now going to want to load those files into Houdini. So I'm going to add a file pattern node, and if I just navigate to the props base mesh folder where I just saved those files, select a file and hit accept, and I'm going to right click and generate node, and I have one work item. When I selected this work item, you might have noticed this headstone updated in the viewport, and that's because when I selected this work item I set the wedge index to 0, which updated that switch. So all of these work items all output a wedge index attribute. So that's something to be aware of, is that some of these attributes are actually common attributes that are shared by all work items and can be overwritten. I come back to my file pattern node. I want a work item for each one of my files. So rather than referencing this file name, I'm going to replace it with an asterisk, which is a wildcard. So this means that any file in this path will be loaded as a work item. So let's right click, generate node, and now I have 7 work items, 1 for each of my file. A middle mouse click on one of the work items, and we can see some more attributes related to this work item. I can see an attribute called output, which is the path to the loaded file, and I also have an attribute for the directory, the file extension, and the file name. And I can use these attributes to reference the base mesh files and load them into Houdini. So if I just come back over to my props base mesh, I'm going to come back up to the object level and into the props process geometry node. And on this first file node that loads the file into the network where I want to process the geometry, I'm going to update this file name to load base mesh. So it's clear what this file node is loading into Houdini. And I'm going to place an attribute into this geometry file field. Now, if I just inspect these attributes again, I could use this output node because that is a path to this geometry file. So let's try that. I'm going to add a backtick and then type at PDG output. Close backtick. And if I middle mouse click, I can see that is resolved to that file path. This looks like it's going to work, but unfortunately, like the wedge index, this attribute is overwritten by each work item. I'm going to add an FBX output, just generate this node, and if I select a work item, we can see the geometry has disappeared from the viewport and we have an error on this file node because this wedge index attribute has been overwritten. So what I'm going to do is, after this file pattern, add an attribute create. Let's name these so it's clear what we're doing here. This is going to be called attribute base mesh file path. And I'm going to rename this file pattern load base mesh. On the attribute create, I want to create a string. I want the attribute name to be base mesh file path, and I want to store on this attribute that PDG output attribute. So I'm going to type backtick at PDG output. Close backtick. And I'm going to right click on that node and generate and inspect one of these work items. And now you can see I have a base mesh file path attribute with a path to the file. Now if I come over to the props process geometry node, and I'm going to update this attribute to base mesh file path attribute. Now we've got an error at the moment, but that's because I need to select a work item. And now you can see I've got the geometry loaded into Houdini. And let's just click through each work item to make sure that's all working. And it is. Now if I add the FBX output, generate work items, and then select a work item, great. We can see that is now working correctly. So by doing this, we've created an attribute to store that PDG output variable that isn't going to be overwritten by subsequent work items. So I'm going to just delete that ROP FBX for now. And after the attribute create, I want to add a ROP geometry output. Let's type in a SOP path /obj/ and I want to go into the props process and select this out process null. And that is the path to this null at the end of this network. So this will run the file through the network to this null, and then this top node will save that result to disk. I'm going to name this node save processed. And update the output file. I want to save this into a folder called props processed. / and again I'm going to use an attribute here, but this time I'm going to use the file name attribute. So I'm going to type backtick at file name and then close backtick, followed by the file extension .bgeo and generate node. Let's middle mouse click and check the expected output. See, it's a bit small, let's double click it and expand this window. And there we go, we can see that's going to be saving that output to disk. Now I want to verify that this is working before I move on any further. I don't want to run each one of these work items because that'll take quite a while to run. So between the load mesh and the attribute create, I'm going to add a filter by range. I'm going to set the filter by to work item index and then leave the filter range as 0 to 1. And if I generate this node, you can see I now only have two work items. Work item 0 and work item 1. So now I can just test the first two work items to ensure that this setup is working. So I'm going to right click on the geometry output and click cook node. This will probably take a little while to cook, so I'll leave it to run and then come back to it in a short while. That's now finished cooking. Right click on one of these work items and click view work item output. And there we can see the high poly model has been generated along with that color mask. Let's just check the other work item. And we have the second large headstone created as well. I'm going to add another tab here. If we come down to tops and add the task graph table. And this lists some information about all of the different work items. I'm going to select the ROP geometry output and we see just the work items for this node. And I can see the cook time here as well. And it took 262 seconds to cook the first work item and 241 seconds to cook the second. And this ran these two work items at the same time. So it was running these in parallel. These topnets can be really powerful in the way that we can run multiple work items at once, and as well as automating the process to save us time. The next step, if I come over to the props game export, is to load the results into this file node and save out my maps to disk as well as the FBX. And I'm going to do a similar process that I did before. After this ROP geometry output, I'm going to add an attribute create. I'm going to create a string, and this time I'm going to create an attribute called processed file path. And the value is going to again be PDG output. And now if I right click, generate node, middle mouse click on one of these work items, and now we can see we've got this processed file path, which is the path to the results of the previous top node. Let's name this attribute processed file path. Now let's use this processed file path attribute to load in the file into Houdini. So on this file node in the props game export geometry node, I'm going to type backtick at processed file path, close backtick. We've got an error, and that's because I need to generate this node and select a work item. And there we go, we can see the results of the processed geometry loaded into Houdini. Let's select the second work item, and that's working as well. Let's just name this file name load processed, so it's clear what we're loading into Houdini. Now, rather than just saving out one output, I have several things that I want to save to disk. I have my mask map, the ID map, as well as the FBX file. So if I go back over to my topnet, let's add a ROP FBX output. And I'm going to use this to save my file to disk. And much like the ROP geometry output node, this reference is a path to a node and then saves that to disk. So in the game's export network, I'm going to delete the ROP FBX output and add a null and name this out FBX. Let's come back over to my topnet and reference that null. So in the export, we've already got /obj, let's add a / and then select the props game export node, followed by out FBX, which is that null. Now I'm going to set the output file. Now rather than using $hip, I'm going to use a variable that I set in the package file when I set up the project. If you aren't familiar with package files, then please do check out the introductory videos where I go through the process of setting up a package file and how we use that with the project folder structure that we used with Project Pegasus. If you haven't set this up, then you can continue to use $hip and then continue to save the files out into the geometry folder. But I just want to demonstrate how we save the files when working within our project folder structure. So I'm going to type $Pegasus demo project. And much like the $hip variable, this points towards a directory, and that directory is the root of my project folder. And I'm going to save my files into the source content folder, which stores all the files that I'm importing into Unreal. So I'm going to type / source content / Pegasus and save that into a folder called meshes demo. I'm going to prefix the file with sm_, which stands for static mesh, which is the naming convention that the Unreal documentation recommends. And then I'm going to use that file name attribute again, so backtick at file name, close backtick, .fbx. And if I middle mouse click and take a look at that file name, we can see that attribute is resolved to the file name. So if I middle mouse click and update the work item, we can see that name updating. So we can verify that that's working. On the ROP FBX, I want to check convert units to ensure that we're saving this geometry. I'm going to rename this ROP FBX to FBX game export. And now right click, cook node. So now what this is doing is loading in the process geometry, deleting any unnecessary attributes, and then saving it to disk. That's complete, and I can view the work item output. And there's my FBX file saved to disk, ready to be imported into Unreal. And if I just double check my project folder structure, I can see how I now have this meshes demo folder with my 2 FBX files. So next is to save my maps to disk. So if I add I'm going to add a ROP composite output. First of all, I'm going to save the ID map, so I'm going to name this ID. And what I can actually do is move the contents of these 2 COP networks into tops. So if I come into the bake ID map, I'm going to copy everything in this network and paste it into this ROP composite output. So if I double click to come inside, I can delete this file node that's in there currently and paste in this network. On the attribute import, I need to update the path to the geometry node because currently it's incorrect. So let's replace this to props game export, and I want the ID map. And as soon as I did that, we can see this color attribute appear in the thumbnail. So that looks like that's working correctly. And I'm going to copy this path and paste it into this second attribute import, which imports that boundary attribute, which I can use to mark the outline of the UV islands. And if I come down to the end here, I'm going to delete this ROP comp, and I need to, on the output null, click this render tag, and that marks that this is the node that I want to save to disk. Let's come back up to the top net. Let's set the output name. Again, I'm going to use the variable Pegasus demo project into the source content folder, into meshes demo, and then into a subfolder called textures. For this file, I'm going to prefix it with t underscore for texture, and then use that file name attribute again. So backtick at file name, close backtick, underscore ID, as this is the ID map that I'm currently saving to disk, followed by .tga to save this into the target format. Now, rather than going into the COP network and updating the resolution, I can actually update it from this top node instead. Just need to set the override default resolution to specified resolution. Then in here I can type 1024 by 1024. I can also copy parameter from the first field and then paste relative reference into the second. So now I can just update the one field and it will update the second. Let's leave it at 1K for now. If I come over to the metadata tab, I want to set the PNG TGA premultiplication to unpremultiplied, and that ensures that I'm going to save this file without an alpha because I don't need one. Now if I right click, I'm going to click cook node and test to see if this is working correctly. And if I look in my folder, in the textures folder, I can see I have those 2 target files saved to disk. And I can just copy this file by holding Alt and left clicking and dragging to create a duplicate. I'm going to rename this one mask. Let's change the output. So update this prefix to mask. And come inside the composite output file. And on the attribute import, I'm going to select both of them and then update this null to point from the ID map null to the mask map null. That's just going to update. That'll take a second or so to cook whilst it updates the color attribute. And there we go, we can see now we've got this updated color map imported into this composite file. And I can click the composite tab just to verify that. There we go, that's updated. We still have the render tag set on this output null. And let's come back up to the top net and cook this node. That's finished cooking. Now if we take a look inside the textures folder, we have those two new maps. I'm just going to come back over to the geometry network, verify that that is working. I'm going to navigate to my project folder structure, into the source content folder, into Meshes demo, and load in this headstone large O2. That'll take a second to load in. Let's add a transform node to change that to the correct scale in Houdini, and then add a quick material. And select one of the textures. So I want the ID map for the second model. And there we go. That verifies that the map has been baked correctly. It has UVs. Let's check the second map. And that's baked correctly as well. Now that I'm happy that this is working correctly, I haven't encountered any errors, I'm happy to run this topnet and process the remaining files. Let's delete those. I can actually delete these COP networks now because they're no longer being used. I'm saving the maps from within the topnet, so let's delete those. And I come back over to my topnet. So what I'm going to do is disable this filter by range node. So when I generate this attribute create, we can now see I have a work item for each one of my base mesh files. Just to make it easier to run the whole network, at the bottom here I'm going to select the 3 output nodes and add a merge. And this is just so I have one node to right click on and click cook node. It looks like a work item has failed. So I'm going to stop this process from cooking and we'll investigate. It's the 4th work item on the processing step where we're generating the high poly geometry. So I'm going to select this work item and come over to the props process geometry node where this step is happening. This is the base mesh for this particular work item, and it looks like I've forgotten to delete these nodes, the exploded view and the name node, which is setting the tag attribute. If you remember, I'm doing this in the previous step when I save out my base meshes. So I can delete them from this step. If I take a look at this blast node, name is incorrectly setting the tag attribute on the wrong geometry, and so it's incorrectly blasting the geometry, and that's causing an error on the remesh grid. So if I now delete those 2 nodes, I now have the geometry appearing correctly, and so will be remeshed correctly. And let's check this on the metal as well. This all looks correct, and check the remesh grid. And now it looks like that's working. So let's come back to the top net. I'm going to right click on the ROP geometry output and click dirty this node to dirty those work items. And try rerunning this again. So right click on the merge, cook node, and now we'll leave that to cook. There we go, that's complete. Let's just check the results on disk. I now have 8 FBX files, and in the textures folder I have all of the baked maps. So this concludes the Houdini part of the video series. In the next video, I'll be moving on to importing the FBX files and textures into Unreal and creating the material. Just to recap, we've explored a workflow for taking simple base meshes and generating detailed high-poly models which we can port into Unreal using Nanite. If you aren't using Nanite in your game art pipeline, I hope you can still see ways of incorporating tops into your workflow. For example, with a more traditional game art pipeline, you could use a setup that generates the low poly geometry using a poly reduce and use nodes such as the Labs Auto UV and Labs Maps Baker to automate the process of generating a low poly model and baking maps from the high to low poly geometry.